Okay, now I'm going to make the path selection the reverse direction. Because as we talked about in regular BGP best path selection, your inbound policy affects your outbound traffic, where your outbound policy affects your inbound traffic. So let's say we want traffic flow to go the same way, that we want the return traffic to come this way, but we're going to make this change from router 3's point of view. So when we trace from 8 to 10, we want it to come in it wanted to go 12, 13, 3. But we're making this change on router 3. How specifically could we do that? Okay, think about the different attributes that we have access to. We saw that the reason that XR2 was making its decision was it was external over internal. So as long as we change anything above that, we should be able to affect path selection, right? So let's say that we're going to do something like AS path prepending. That as we send the update from router 3 out to 12, we're going to add an additional AS in the path. So it's going to be 1, 2, 3, 1, 2, 3, versus as we're going from router 3 out to router, so that's XR2 versus XR3, it's going to say 1, 2, 3. So we should then choose the shorter AS path. So the way we're going to do this is from router 3's point of view. We're going to match the particular next hop. Okay, the next hop is the one that is on router 2 is the next hop. So on router 3, we're going to say IP prefix list 2, permit 2222, 32. Route map is out to XR2 to permit 10. It says match IP address prefix list 2, set AS path prepend, and add 123, 123. Okay, everything else we're going to permit. Okay, then if we show run router BGP, we're going to say when we set the, or show run pipe section router BGP, when we send a IPv4 update out, we're going to apply this route map that is out to XR2, out. Neighbor route map. Okay, we're then going to send the new update, so clear IP BGP star out. And if we go now to router 8 and we do the trace route, ideally this should go from 12 to 13 to 2, which it does. Okay, so we basically did the same thing. We changed the path selection, but we did it with a different attribute, and we were doing it from 3 outbound to XR2, as opposed on XR2 to doing it inbound. Okay, right now it looks like everything is fine. Okay, now let's check the other customer side, which what this made the change was between 10 and 8. Okay, now let's check reachability between 4 and 7. So we go to 4, we trace to 7, we broke it. But the only change that I had made here was this route map out to the neighbor. Okay, let's say I'm going to roll back this change just to be 100% clear that this is the problem. That if we go under address family IPv4 unicast, we're going to remove the route map and then do clear IP BGP star out. Then we do a ping from 4 to 7. Ping 7777, source 4444. It works. Okay, I put the route map back in, clear the BGP process again. Now it's broken. Okay, let's look at specifically what the route map is doing. Do show route map. It's this one out to XR2. Let's say do show run pipe section route map. It says if it's prefix list 2, do prepending. If it's not prefix list 2, don't do anything. Just allow it out. Okay, someone had asked the question, could we also do med? Med would have worked the same way. So we would apply the med to be a higher value out to XR2. That should to make it more preferred XR3 for the traffic to come in. So the path selection worked, but it broke the other customer. Why do you guys think that that might happen in this case? And it's kind of an obscure problem, and as far as I have found, this is not documented anywhere in the documentation. Okay, if we go to the other end, let's go to XR2. And as I mentioned before, I was going to talk about why would you do both labeled unicast and unicast in from the neighbors. Let's look at now the difference between the show BGP IPv4 labeled unicast and the show BGP IPv4 unicast. Okay, what is different between these two outputs here? And it's very easy to miss here. We're going to have to look at this side by side between both of these outputs to see really what is the specific problem. So let's look at let's see, how can we see this? Okay, that's a little bit easier to read. And then let's look at this for well, we could just look at it like this. Okay, so this one is the which output? This is the labeled unicast output, and we want to compare this to the unicast output. What's specifically different here? What happened to 3333? In the output of the left here, we have two paths to 3333. On the right, we only have one of them. What this means is that the label got stripped. In a regular iOS, if you modify an outbound attribute of an IPv4 labeled unicast route, it strips the label unless you specifically tell it not to. So what the problem is here in this case is that from XR2's point of view, if we say show IP route to 2222, it says I'm using 13 to get here. If we show MPLS forwarding table for the prefix 2222/32, it says use label 16,004 towards 13. Okay, this is how we're switching the packets from 8 outbound. So when we do that trace, this specific label number, well, it's not that one. It is the well, actually, it broke both of them in this case. Why is it breaking this one too? Oh, you know why? Because it dropped the BGP session now. BGP to router 1's broken because the label got stripped for this as well. So the issue was that router 3 was saying match the prefix 2222. Apply a policy out that way that is adding autonomous systems onto the path. So it's 123, 123, 123. And then in this direction, we're sending it as just 123. Okay, so for this particular route, it goes this way. XR2 says, I'm not going to use the local route that came in from 3 because it has longer AS. I'm going to use the one that came in from XR3. That one is coming in as a labeled unicast route. But the other two next hops, which are 1111 and 3333, XR2 is going to prefer to use the unlabeled path simply because we're preferring the external peer over the internal peer. So same decision as we did before, but the problem is now when we redistribute that from BGP to IGP, we can no longer connect the label together. So if we look at this from XR2's point of view and say, well, we know how you were routing to get to 2222. How are you routing to get to 3333? It says I'm going to go to 12.3, and if we show MPLS forwarding table for this particular prefix, there's no label. Now the solution for this is straightforward. It's just that the problem is pretty obscure. That we need to say set MPLS label on the explicit permit of the route map. Now within the scope of the lab exam, you should have, if you were to run into this problem, the way that you should have troubleshooted it is that we should have tested connectivity before we did any changes to path selection. Then we made a change to path selection, connectivity is broken. Well, we know whatever we change has to have something to do with it. But the potential problem is that if you're not doing your verification step by step as you go along, it could be easy to miss this problem, and then you spend all sorts of time troubleshooting your VPN v4 peerings, your underlying IP routing, and it has to do with, just in this case, that router 3 is stripping the label as it goes out to the remote neighbors. So to get back to the question, as some people had before, is why did I use both labeled unicast and unicast, is that you can have a case where you may not want to use a label for the particular route. So if we show IP route for 333, or let's say show IP Ceph, show IPv4 Ceph, or show Ceph IPv4, and the destination is 2222/32 versus 3333/32. Both of these routes are learned via BGP, but the difference is that one of them is labeled unicast, one of them is regular unicast. And that should tell us also in the regular routing table that if we show IP route 2222 versus show IP route, well, that one's being learned through ISIS because of the redistribution. But 3333 is coming in from labeled unicast address family, but there's no actual label that's being learned. If we show IP BGP labels, or show BGP IPv4 unicast labels, this does not have a label out to, let's see, it says 12.3 is received label 3. Or no, wait a minute, this is the problem. That likewise had no label. What I would also need to do, so actually there's two changes I need to make here. If we show run section route map, is that I would need to say set MPLS label here as well. So not only under the explicit permit at the end, basically every single section of the route map. So now if we clear BGP, or just clear IP BGP star out, now we should be learning labels for 2222, which we are. Okay, it technically shouldn't have affected connectivity though, because if you look at the path selection, we weren't using the path that was unlabeled. But figure within the scope of the lab exam, there's a lot of different ways they could ask the question. They could say, go that way, and if that way fails, fall back to the other one. So you change path selection, it works one way, you try to fail it back and it doesn't work because the label gets stripped from iOS out to the other end. So the point of this is that if you were to do in conjunction option C plus outbound modification of attributes in regular iOS, you have to make sure to add this additional statement, which is to say set MPLS label. So now if we look at from XR1, we should see the BGP peering now came back up because we regained the label path to them. And then when we trace from the customers, we trace from 4 to 7. This should now work, but it's going likewise the path that we want from 12 to 3. Then if we go to router 8 and we trace, this should be going from 12 to 13 to 3. This was the path selection change that we made by modifying the autonomous system path. Okay, there's a question here. Is the received label out and the local label in that output, which is the output on who? On XR2? Show BGP IPv4 unicast labels. Yeah, you're correct. Receive label is out. Local label is in. So this means that when I send traffic to 2222, I'm going to use 16,004. So if we look at the show Ceph IPv4 for 2222/32, it should say imposed labels is 16,004. Then if I receive traffic in from another name, well actually that's a bad example because both of the numbers are the same there. Let's say something else. Let's say 3333. 3333. It should say labels imposed is 3. And this is labels imposed implicit null, implicit null. This is because, well, we're directly connected to them. That's kind of another bad example here. Let's say 1111. 1111. It says impose label is 16. 16 is the receive label. Okay, so there's a question here. I didn't fully understand why before I created the iBGP session between router 3 and XR2, I said that we can't do traffic engineering by tweaking the BGP attributes, yet we're advertising the same prefixes. Okay, so the issue was that router 3 was doing a BGP peering to XR3 and to XR2. But between them, they weren't doing an iBGP peering. So this means that if I do, let's say, AS path prepending out to XR3, XR2 is not going to know about that, so it's not going to change its best path selection. Basically, we're learning two eBGP routes, both with a distance of 20, and we're doing redistribution into ISIS both ways. So this means that they're both going to learn an ISIS route with a distance of 115, but this would never get installed in the RIB in the routing table, simply because ISIS has a larger distance than BGP. Now, it's not going to affect XR1 because ISIS is link state. We have to advertise the route regardless of whether we're using it. So the ISIS route would be advertised this way, and XR1 would say, I'm going to use the distance 115 route to get there, but then as soon as the traffic is received in XR2, we would always choose this link regardless of what the BGP attributes that router 3 is setting outbound. Because in that case, it's not a BGP to BGP decision, it's a BGP to ISIS decision. And eBGP wins in that case because of the administrative distance. So the fix is that if you do want to do path selection and have XR2 and XR3 compare against each other's attributes, you need to either have them as a client of a route reflector, as someone just mentioned. That's a possibility as well. But somehow they need to be exchanging the IPv4 routes. So BGP comes in here as eBGP, then it needs to send it that way as iBGP. And then likewise, XR3 learns the eBGP route. So it's basically saying that I have A instance 1 and A instance 2. Now I can run best path selection against these and figure out which one that I'm going to install based on the BGP attributes. But in that case, the decision is not made based on the administrative distance, it's made based on BGP best path selection. Now eventually we got to the point where we preferred external over internal, but that's not part of the distance, because the distance calculation is not made until after best path selection is chosen, and we go to move the route from the BGP RIB to the global RIB, from basically the BGP table to the routing table. There's another question here. How did the metric values come out to be different? The reason why, and what the MED was referring to, was the loopback of XR1. That from XR2's point of view, this loopback is 1 hop away. From XR3's point of view, it's 2 hops away. And each of the hops in the case of ISIS is a metric of 10. So XR2 says the metric to the loopback is 10. XR3 says the metric is 20. When we did the network statement into BGP, both regular iOS and iOS XR automatically copy the BGP MED, or the IGP metric into the BGP MED. So it's basically telling the other autonomous system, use the shorter internal path from my point of view, and I'm signaling that to the external BGP peers by default. So we could have changed it in order to modify path selection, but just be aware of that is part of the default behavior, that since the MED gets copied in, even if you don't manually change it, you're affecting the other remote autonomous system.